So hi guys, today's sorry I forgot the date. Yeah, today is 28th of November, and today we'll be solving this today's uh, Leetcode daily challenge problem. Due to my exams, I was not able to continue that series. So from now, I will be continuing that. I will be like I won't be able to upload on a regular basis, but I will try to solve. Upload as many videos as possible. So yeah, today we'll be solving this problem. This is like a fairly straightforward and easy problem. What the title of the question states that all paths from source to target. So like the the title itself makes the problem very clear that what we have to do, but then also there is some twist. Like it's a very easy problem. uh, you will be able to solve this problem if you know, like, only if you know DFS and backtracking. So yeah, so given a directed acyclic graph of n nodes labeled from 0 to n minus 1, find all the paths from 0 to n minus 1 and return if any in any order. Like we have to, okay, let's further read this problem, then I will explain you what we have to actually do. The graph is given as follows. The graph of I is a list of all the nodes that can be visited from the node I. That is, there is a directed graph from I to, okay, like this is this part is basically giving us idea about the graph, that the graph is a directed graph, and they will be giving us the like graph in the form of adjacency list. So let's go through what they have basically state, that we have to reach from 0 to n minus 1, and while we are doing this, like we are moving from this to this, we have to then return them all the possible paths from this to this. So and also the graph is like directed acyclic graph. So yeah, so what we have to do basically, we have to reach this node. For this particular test case, the output will be 0 1 3 0 2 3 0 1 3 0 2 3. For this test case, we have to reach from 0 to 4, so 0 1 4 0 3 4 0 4 0 1 3 and 4 0 1 2 3 4. So you can accordingly have a look at all the test cases, and I will be stopping for like a video for a minute so that you all can pause and have a give it a shot, and we will meet in like a minute if you all solve. Otherwise we will be meeting in a minute as well. So I hope you all tried this problem. So let me discuss the solution approach. So what we will be doing is, uh, first of all, the giving, like, we want to know the path, so we can either use like the depth of first traversal of the graph or the breadth first algorithm, but I personally prefer finding path kind of thing. I feel like DFS is much more easier to visualize how the problem will be solved. So I have used DFS, but you can solve this using BFS. It's like a very similar approach. So yeah, so I will be using DFS. So what, for performing a DFS algorithm, we in general graph, we maintain like a true boolean array, which basically states that whether we have visited a node or not, so that like we did not get we did not end up with an infinite loop. So but here, like as it is directed an acyclic graph, DAG, it is also pronounced as DAG, the like short form informally. So it's a acyclic graph, which is there will be no cycle, so we need not to use that boolean array. We can directly use that we can directly con on any node and visit all children, and being like we can be sure that we will not visit that node again, as there is no cycle. There is like, if there is no cycle from a node, we can only visit like there is only unique path through that node. Like here you can have a look, like if we from if to visit a to visit have a visit at 3, we can only visit like this. There is no other way to visit. You can try out the possibilities. There is no other way, so we can be sure that we can visit a node we will visit a node only once, so we need not that boolean array. Yeah, so here is the solution approach. What I'm these are like my not answer, this is my answer array. That the answer, like here we they have uh, they have said that we need to return a vector of vector, which basically means that a particular vector will contain the path from source to the destiny. So and the target will be I have maintained target because I personally feel I like maintaining this target kind of thing. This basically very like makes your code very readable. So I have initialized this target, which is like a member function, member variable, sorry. So it is like the target we are trying to achieve. So graph dot size, basically graph, as they have given us adjacency list, the graph dot size will be give us n, and the target is n minus 1, so that's a target, like target will be n minus 1. So here yes, so this array will store the, like while we are performing DFS, the temp will store intermediate nodes from source to destiny. So here like 0 3 4 for this route, if and we are passing this uh, by copy. So like if we are on one node, so we can visit 1 2 and 3 node. So like many of you might have tried by passing by reference, but if we suppose pass that vector by reference, then uh, for this route, suppose you push 0, then you pushed 1, and DFS, suppose we initially called this node and we found out that yeah, there is 4, so 0 1 4 is pushed into our this answer array, whatever you might have maintained for returning the answer. Now for if we again call 0 1 and 3, then in this array, like in this vector, this temp, you initially will have, if you pass by reference, then while calling at 3, you will also have 0 1 and 4 in that vector. So this will create an array. It will basically state that you started with 0, then went to 1, then went to 4, and then you came to 4. That's not possible. You won't be able to, there is no route from 0 like 4, from 4 to 3. So that's why you should pass by value. Sorry, yeah, you should basically yes, pass by value. Or one thing also you can do, you can, like as soon as you complete this, like 0 1 and 4, you can pop the last member of this vector, like 0 1. Suppose you came here by, from initially you went to 0, then you came here at 1, then at 2 3 and then 4. So this is your destiny. So from 4 you might have called this. So if you remove this, then again this, then again this, and then again this, so initiate here, by the time you come here, yeah, by the time you visit at 1, you will have your vector released. Your vector will not contain this. This is kind of backtracking, but you can't say 100% back. Yeah, it's a backtracking. Yeah, sorry, I kind of confused between that. I was revising the definition. Yeah, this follow the definition. Yeah, so this will be backtracking. So you can perform either of the operation. The backtracking approach will be relatively less space, it will be more space efficient approach, but I have used passed it by value. You can perform by either of the way, the both of the will be accepted. like when you're solving question, your main approach should be reduce the time. I personally things like that. So this is how yeah, so this is our DFS algorithm, where we are start in accepting this start from where we are, uh, the node at which from we are right now, and this is our graph, and this is our that temp that I passed from here. So if we have reached our target, we will push our st in our temp array, then we will push that array into our answer array, and then we will return. Otherwise we may call to all the childrens, and accordingly this will be like recursively call on the childrens, then accordingly the problem will be solved. At the end I have returned the answer. Let's submit this problem. Let's see what we get. First of all, give it a run so that we will be sure that there is no any error, and we are passing basic test cases given by our. You can also, if you don't know, like you can write your own test case here, and you can run the algorithm. It will show you the correct, like for that input it will show you the correct and what is your output. Like if you want to test by your own algorithm, I am submitting this problem. Yeah, the solution got accepted, you can see. I have a suggestion that don't you you should also have a look at other solution here, because some of them might have even written a much more efficient algorithm than yours. It's not like you should take edit, like you should not get something feel like your solution was incorrect. Your solution was correct, but like in algorithms there might be many algorithms to solve the one, so you should have a look at others as well. If it is more efficient, then you should try to understand that algorithm, and then you should also like how that algorithm was more efficient. Then you will, like if someone asks you an interview, then you will be able to give them the most efficient algorithm. So yeah, this is it for today. Thank you all. We will meet in another video.